Okay, so this one 13.1B, we have done 5 and 6. We'll go to B7 now. Okay, let us see that. Shanti Sweets stall was placing an order for making cardboard boxes for packing their sweets. 2 sachets of boxes were required. The bigger of dimension 25 into 20 into 5 centimeter and smaller of dimension 15 centimeter into 12 centimeter into 5 centimeter. For all the overlaps, 5%. Okay, 5% of the total surface area is required extra for the overlapping of the boxes of each box. If the cost of the cardboard is rupees 4 per 1000 centimeter square, find the cost of cardboard required for supplying 250 boxes of each kind. Okay, let us start with the bigger box. Here, the bigger box dimension. Here one is bigger, the other is smaller. So let us suppose this is the bigger box. Whose dimension is, as mentioned in the question, 25 into 20 into 5. Length 25 centimeter, breadth 20 centimeter, and the height 50 centimeter. And then there is a smaller box. Let us suppose this is the smaller box, and the dimension of the smaller box is 15 into 12 into 5. So 15 centimeter into 12 centimeter into 5 centimeter. So here, dimensions of the bigger box, let us say. Dimension of the bigger box. Let us represent length by L capital, 25 centimeter. The length B is 20 centimeter. Its breadth, and H capital, let us say 5 centimeter. Its height. Okay. So this is the dimension of each bigger box. So they are telling you to find how many cardboard area will be required and the cost of it, or the cost of it. So we have to find the total cardboard area required for bigger boxes. So that will cover surface area of each bigger box. That is the cardboard area required for one box. There will be formula we know is 2 into LB plus BH plus LH. So this is the total surface area, or surface area of each box, total cardboard area required. So that will be equal to 2 into L is 25, B is 20 plus B is 20 into H is 5 plus L is 25 into H is 5 again. So centimeter square, because area is 2-dimensional. So moving from here, if we were to go here, 2 into 25 into 2 is 50. And we add that 1 0 here. 5 2s are 10, so 100. 20 into 5 is 100. 25 into 5, 5 5s are 25. 2s are 10, 11, 12. So centimeter square. 25 into 5. 125. So 2 into, this is quite easy. 5 plus 500 plus 100. 600 plus 100, 725. So this much is the cardboard area required for each bigger box. 2 5s are 10, 2 2s are 4 plus 1, 5, 2 7s are 14. So 1,450 centimeter square. Okay. Now to make the box cardboard, a little bit of extra overlap is required, and they are saying, the textbook is saying, yes, 5% of total surface area is required. So let us write here, and okay, and area of overlaps, okay, required for each bigger box, required for each or one bigger box. The question is saying this area of required for each overlap required for each bigger box is 5% of total surface area. So 5% of total surface area, which means there will be 5, and if we remove percent, we know 100 comes in the denominator. Of means multiplied, and total surface area or surface area is same, so this one is the 1450 centimeter square. So this 0 and 0 cancel. Okay, and this 0 is very easy to divide, so even though we can cancel, we just keep it. Then 5 5s are 25, 5 4s are 20, plus 2, 22, 5 1s are 5, 6, 7. So 1 0 means decimal will move one place to the left, so it will come between 2 and 5. 7.25 centimeter square, 72.5 centimeter square. Okay, so that is the total surface area or overlaps that is going to be required for each bigger box. So therefore, let us calculate here. Okay, you can just go here now. Let us write here, therefore, total cardboard area required. Let us find out for total cardboard area required for 250 bigger boxes, 250 numbers of bigger boxes. For one box we have found out for 250. That means 250 multiplied to total surface area of each bigger box for 50 plus the overlap area 72.5, and then we can write here centimeter square, right? So 250 into, we need to add these two, so 1450 plus 72.5 means you also 0.0 with, you can put 5.2, 12 and 5, 1522.5, 1522.5 centimeter square. So now you can rub out this area. You can write these things on your rough. Okay, so here from here we come, and then we can calculate. This 0 means 10, so decimal that will multiply to 0. Decimal multiplied to 0 means decimal move right, so no more decimal. So 1 5. Okay, let us do it here rough, smaller space. So 15225. Because of this 0, the decimal is removed, and therefore only 25 is left. So when we multiply these two numbers, we will get the total cardboard area required for 250 bigger boxes. 5 5s are 25, 2 are 10, 11, 12, 11, 25, 26, 5 1s are 5, 6, 7, 2 2s are 4, 5, 2 2s are 4, 2 5s are 10, 2 1s are 2, plus 1, 3, 5, 2, 6, 10, 8, and 3. So we're going to get equal to 380,625 centimeters squared. Let's give this one as a question 1. The total cardboard area required for total 250 big box. The total area required Now let us calculate for each small box surface area or total surface area of each small box. We know formula is box is cardboard or cuboid only, so 2 into small LB plus BH plus LH. So if I apply this formula, you're going to get 2 into small L, as you can see here, 15 into 12, BH 12 into 5 plus LH 15 into 5 and centimeter square. So I said write these things on your graph, okay, it will help you. Then here we can write your 12, okay, 12 into 15 into 12, 2 5s are, okay, 15 into 12, 2 5s are 10, 3, 5 and 1, 0, 8, 1. 180 for multiplying these two. 180. So now next 12 5s are is 60. 15 into 5, 5 is 25, 75 centimeter square. Then we can write here 2 into 100, 240 up to here, 240 plus 70, 310, 315. When we all this add, you can try on the rough to make sure if you want. 2 5s are 10, 2 1s are 2, 3, 630 centimeter square. That's what we're getting for each smaller boxes. And just like we did for bigger boxes, same way, an area of overlaps required for each small box. Area of overlaps required for each small box. Again, the question has said 5% of total surface area of the small box. So that will be equal to 5 by 100, sorry, 5%. Correct, this one 5%. So if you remove the percent, then 100 will come in denominator. Once we remove percent sign, percent simply means divided by 100 into total surface area of each box is 630 centimeter square. So we can cancel this 0 and 0. Just like as we did earlier, this 10 is very easy to divide, so let us not cancel any further. 5 3s are 15, 5 6 are 30 plus 1, 31. 1 0 means decimal move between 1 and 5 to the left, 1 place because of 1 0. So 31.5 centimeters square is the area of overlap required for each smaller box. Then we can write here total cardboard area required for same thing, only same process, 250, but this time small boxes, smaller or small boxes will be 250 multiplied to, just like we did for bigger box, this one, it's one surface, total surface area of one small box, and overlap required for each small box 31.5. You add it, and then we're going to get here 250 into 630 plus 30, 661, so 661.5 centimeter square. It's like this, 630.0 and then 31.5 we add means 5.1666, 61.5. That's how you're getting when we add these two, like I showed on the graph. If you want, you can write it down. And next one is this one, equation number 2. Let's come from here. The things are written, so from now here, from here we get the equation 2. This 0 will, 1 0 means multiplied to decimal means decimal move to right, so 1 0, 1 place to right, so 6615, no more decimal, multiplied to 25, so 5s are 25. 5 1s are 5, 6, 7. 5 6 are 30, 3 9, 5 6 are 30, plus 3, 33. 5s are 10, 2 1s are 2, 3. 6 are 12, 2 6 are 12, 13. 5 7 3 5 6 1. So you're going to get equal to 1 6 5 3 7 5 centimeters square. This is the total cardboard area required for 250 small boxes, including its overlaps. And the bigger one is this. So when we add these two, we're going to get a total surface area of cardboard required to make all these 250 small box and 250 big boxes. Okay, so we'll total. So let us write here total cardboard. We'll need some space, so we don't need this anymore, so just write here total cardboard area required in total. Everything will be the total cardboard area of bigger boxes 380,625 plus 165375, this much centimeter square. And we can write here since using equations 1 and 2. We are coming to the last few steps. So here, therefore that will be equal to, when we add 380,625 and here 5 7 3 5 6 1, we're adding both plus, so 5 plus 5 10, 7 plus 2 9 plus 1 remainder 10 again, 1 remainder, 6 plus 3 9 plus 1 remainder again 10, 5 plus 1 remainder 6, 8 plus 4 8 plus 6 14, 1 in hand, 3 plus 1 4 plus 1 remainder 5. So 5 4 6 000 centimeters square. This is the whole total cardboard area that is going to be required to make 250 bigger boxes and 250 smaller boxes, including its overlaps. The question is asking for the cost, so you can write here. Therefore, let's write here. It's not hard, but we need to do carefully. This one is a bit long, right? So there, you see there, and the cost of cardboard required. So total cost of cardboard. We know cost is always, as we learned in previous, also area multiplied to rate. So total area is 546,000 centimeters square multiplied to the rate, liter rupees 4 for 1000 centimeters square means 4 rupees 4 divided by 1000 centimeters square. That's the meaning. This centimeter square and centimeter square cancels. 1 2 3 cancels. 1 2 3 cancels. So we're left with rupees, and this 4 will multiply this portion. 4 6 are 24. 4 4s are 16, 17, 18. 5s are 20, 21. Rupees 2,184. One more question, B8. So we can write that down. So B8. Last question for test 13.1B. Parveen wanted to make a temporary shelter for her car by making a box-like structure with tarpaulin, means polythene-like structure material that covers all the 4 sides and the top of the car with front face as flap, which can be rolled up to open it up. Assuming that the stitching margins are very small and therefore negligible, how much tarpaulin would be required to make the shelter? Height 2.5 with base dimension 4 meter into 3 meter. Since the shelter, according to question, is of height 2.5 meter with base dimensions 4 meter into 3 meter. So 4 into 3 meter. So the shed will be something like this. Because of this, the height, the base 4 or 3, so 4 and 3. So the shelter will look something like this. Therefore 4 and 3, so okay, something like this, the car shelter. So let's just draw it the normal way we have been doing so far, like this. So overlap it like this, and then here base is 4 meter, length into breadth 3 meter, and the height is 2.5 meter. So he wants to roll this front part rollable, but everything else is stitching margin is negligible. So this is the area required for tarpaulin. So here therefore dimensions of the car shelter as given in the question here. Base dimension 4 into 3 means L is 4 meter length, B is 3 meter breadth, H is 2.5 meter, let us say. Since one more question is there, assuming the stitching margins are negligible, okay, box-like structure with tarpaulin covers all the 4 sides. So we can write here, since tarpaulin covers all the 4 sides, means the 4 walls, and the top. So it must be covered the top also. But the bottom we're not going to put tarpaulin. So only these 4 sides and the top. Therefore, tarpaulin. What the question is saying, how much tarpaulin will be required? Tarpaulin required, our answer will be 4 walls area as indicated in the question. 4 walls area plus top area, because that's what the question is saying. Cover the tarpaulin with on the 4 sides and the top only, not the base, not the floor. So 4 walls area of a cuboid is twice h into L plus B, plus the top is this part, the rectangular. So this is L, this is B. So L into B is the area of the top. So now we can put here twice into 2.5 because h is 2.5, L is 4 plus B is 3 plus 4 into 3, and instead of putting here and there we put a second bracket and put here meter square. So we do that. Then 2 into 2.5 is 5, 4 plus 3 is 7, then plus 4 3s are 12 meter square, then 5 7s are 35 plus 12 meter square, 30, 47, 35 plus 12, 47 meter square is the total tarpaulin area that is going to be required. Okay, so that concludes the part 4, test 13.1B. Okay.